The time sight was an important method in celestial navigation. Its theory had been known since the development of spherical trigonometry, but it could not be used effectively at sea until accurate marine chronometers became available. The method was based on the navigational triangle. The declination or polar distance of the celestial body was taken from the nautical almanac. The zenith distance, or co-altitude, was obtained by observation. If the ship's latitude was already known, the navigator had 3 sides of the triangle and could calculate the meridian angle. By comparing this with the Greenwich hour angle from the almanac, the ship's longitude could be found. Although the time sight was mathematically correct, it had an important weakness. The longitude obtained was only as reliable as the latitude used in the calculation. In reality, the result did not give an exact position, but only a point on what is now known as a line of position. If the observed body was on the prime vertical, a small error in latitude had little effect on longitude. However, if the body was near the meridian, even a small latitude error could cause a large longitude error. The importance of the line of position was discovered in 1837 by Captain Thomas H. Sumner. During a voyage from Charleston to Greenock, Kay's ship approached the Irish coast after several days without reliable observations. Because the weather was thick and the ship was near a dangerous lee shore, the dead reckoning position was uncertain. Sumner observed the sun and calculated longitude using the estimated latitude. Then, doubting the latitude, he repeated the calculation with latitudes 10 and 20 minutes farther north. He noticed that the 3 calculated positions lay on the same line, in the direction of Small's light. Sumner realized that the same observed altitude must have existed at all points along that line at the same instant. Trusting this conclusion, he steered ENE and soon sighted Small's light, confirming his discovery. In 1843, Sumner published a new and accurate method of finding a ship's position at sea by projection on Mercator's chart. He proposed solving one time sight twice, using latitudes on either side of the dead reckoning latitude and joining the 2 resulting positions to form a line of position. This Sumner line marked a turning point in practical navigation and became a foundation of modern celestial navigation.